And etched bronze or etched metal, which is typically a chemical process, quite easy to obtain, but you can get really interesting finishes, and it's a very scalable material for smaller projects. So these are materials that we're currently using on projects right now. This is a double embossed stainless steel, again using lighter gauge material, but imposing a pattern into it to make it more rigid. And then it can also be painted or coated, and then we can take off the outboard surface of the coating. It's for contrast. So here's some projects using metal. This is a project, Northeast Trade Tower, Kohn Pedersen Fox, where we used sheet aluminum to hold the sculptural shape of the tower within the glass curtain wall. This is Scripps Neurosciences Institute in La Jolla, California. It's remarkable. This is a 316 stainless steel glass bead blast project close to the ocean. It was a little frightening at first because we were concerned about disturbing the stainless steel, the protective coating that comes out of right out of the mill. But glass bead blast, the building is now, I think it's almost 15 or 16 years now. The building still looks the same. It's held up remarkably well. So it's all open joint rain screen stone, and this is all 316 stainless steel. All of the exposed metal here is all 316. So it's a lovely soft finish. You can see it just wears beautifully. The most memorable, well, I found it funny, but we had like 100 kilo iron workers and glazers setting the materials on the project. But because the glass bead blast, we were so concerned about getting it soiled, we had them wear little white gloves. So we had these big guys wearing these little white gloves. Excellent. This is not my favorite piece of architecture, frankly, but it's a massive metal cladding project in the sense that it was a very good solution given the scale of the project. Another little side note is the owner of the Dallas Cowboy football team he's a billionaire, and it was quite a secret project in the sense of what it looked like. So he actually, instead of hiring a contractor, he had us build the visual mock-up, which was full scale. He came out in his Texas accent and he said, I thought it was going to be bigger than that. It was full scale. So it's funny how people look at things differently. This is a Project Phoenix Art Museum where we used two different materials. We used bronze material. This is a very subtle application of bronze, and then just to offset this very high span single light glazing, and then zinc. This is a project in Boston at Diller Scofidio, and a very subtle aluminum cladding element that provides a structural, or provides a kind of a sculptural message in the facade. It's a very tight facade, and then there is this band of formed aluminum. This is a project, it was the first, well, rain screens have been around for centuries, of course. Then we got away from rain screens in some parts of the world, and now hopefully we're all going back to them. So this was one of the first modern rain screens in India. It was actually our first project in 2002. And this is all sheet aluminum, all open joint. It's right on the Arabian Sea in a heavily polluted environment. And the client is really very happy with it because it is not soiled. It stays very clean, and the incremental cleaning costs are far lower than they would have been if it had been a wet system. One of the, we have to be careful as facade consultants, because sometimes architects use terms to sell their design to a client. So this architect, who we do a lot of work for, they described these as sunshades. Well, we did the modeling, and the modeling really didn't support the idea of a sunshade. So we asked, could we call those architectural features? And we could call them architectural features privately, but not in front of the client. So this is blackened stainless steel. You can see the organic nature of it. This is also a chemical application, so it's a electrochemical application. So you can see the organic nature of the material. This is a Jean Nouvel building. Right next to it is Rem Koolhaas project, and next to that is a Mario Botta project. So it was funded by the chairman of Samsung. And now there's the last building, the Gateway building, is currently under construction. And this is a good example of what the specular character of stainless steel can do. This building is already a tall building, but when the sun hits the directional stainless steel, it just lengthens the building. This is UCB, East Asian Library at the University of California, Berkeley. So copper, a lot of bronze, and again, it's all a rain screen open joint system, but the bronze really provided richness to the project. Interesting, again, side story is Todd and Billy are, I've known them for 17 years. They don't design buildings with pitched roofs. All their buildings have flat roofs, except for this one. So this architectural photographer backed up to a certain angle to take this photograph so it wouldn't show the roof. That is great. So you can see these are castings, but really what happens is when you go inside, this perforated bronze sheet really softens and gives it this very nice character inside. And then again, the cladding of the bronze and spot cladding. So you don't have to do an entire building with this material. You can highlight certain areas of the building. This was a modeled non-directional finish, which is now, California, things don't patina quite as quickly as they do in some parts of the world. This is a good example of copper cladding where people not really concerned about it being soiled, or because copper has that unique characteristic where it just weathers and people accept the way it weathers. So this is a school. It's principally a dance and ballet school in Manhattan, and it's aging beautifully, not evenly but beautifully, and it's made up of different gauges of copper, but it's all kind of mellowing together. So this is the project I mentioned where we're using 3 different colors of anodized aluminum, and the idea is that this is a hotel, a W hotel, and actually it's a Le Méridien hotel, excuse me. So the perforations create this iconic floral pattern, which we're seeing more and more now, where buildings take on a branding element in the facades. So a perforated sheet aluminum is a very effective way of doing that. These are some of the early renderings. The project is topped out, and the facade's going on right now. If I showed you the photographs under construction, it wouldn't be too attractive to you. So these renderings show how the light is coming through these perforations and supporting the branding of the hotel. So there's some 3 trends that I just want to touch on briefly. Because of parametrics and advanced geometry and computer modeling, then the challenge is how do we get metal to conform to that idea? when we form glass, we can use computer modeling to change the shape of the glass by changing the viscosity of the glass, and then the glass slumps or is molded to those computer models. In metal, it's different because we're not typically changing the viscosity or the rigidity of the material. So this is an example of a project where there are very few panels that are the same. In fact, I'm not sure if any of them are the same. So how do we do that using a sheet material cost effectively? So this is the mock-up, and you can see the kind of we call them potato chips. You know, they take on an individual shape. So how do we do that, and how do we do that using computer technology where it transposes the information from the design to the submittal shop drawings and then on to fabrication? So this is a technology where all of this data is put in. You can see this is whited out because that part of it is highly proprietary. But you can see where these parametrics and contours go into the computer, and then they're created and then they're formed. Basically, it's just two dies, essentially, that are made by computer control that press the aluminum into the proper shape. So before, this was an extraordinarily difficult and expensive process. Now this process is coming down in cost because of the technology. The next issue, or the next trend that we see is this nanotechnology where coatings are allowing for the use of metal in ways that we didn't anticipate before. So one of the issues, especially in urban environments, as I touched on with the Kenyang building, is how do we keep these facades clean in highly polluted environments? So the advent of, not the advent, but the addition, if you will, of titanium oxide to coil-coated paint finishes is a wonderful characteristic that now allows us to use lighter colors and keep buildings cleaner.